In this video, we shall discuss on the characteristics function for the geometric distribution. We are also to look for the expectation and variance for the characteristics function of the geometric distribution. For more on this topic, you need to subscribe to this channel. The first thing to do is to write the characteristics function for the geometric distribution, and it is stated as p exponential it all over 1 minus q exponential it. So, the first thing to do is to find the expectation, of x. So, to obtain the expectation of x first, it means we have to find the first derivative of the characteristics function. And the first derivative of the characteristic function will lead us to what is called the quotient rule. We employ what is called the quotient rule of differentiation, which says that v du all over dt, because we are differentiating with respect to t, minus u dv all over dt all over v square. So our characteristics function for the geometric distribution will now give us v, which is this. We write it as 1 minus q p I t. The u all over the t, that means the u all over the t will differentiate this. If we are differentiating this, we have p I exponential it. The I stands for the characteristics function. Now we have minus u, which is p exponential it. Then the v all over the t. So we differentiate this, the v all over the t. We differentiate this with respect to t. If we differentiate that, we get negative q characteristics function exponential I t. So this is what we get all over v square 1 minus q p I t all square. So this is what we get, which is also equal to, now we can open these brackets to give us p I exponential it minus this will multiply this to give us q exponential it multiplied by p I p it. Because of this sign, this becomes positive. So for more on this topic, you need to subscribe to this channel. So because of this sign, this becomes positive. So we write plus this multiplied by this. We have q I p, which is exponential it, and p exponential it all over 1 minus q exponential it raised to the power of 2. Of course, if we watch at this, we see that this and this are the same. Just like negative 1 plus 1 is equal to 0. So if this holds, it then means that our characteristics function for t is equal to this will cancel this to give us p I exponential it, where the I stands for the characteristics function all over 1 minus q exponential it all square. So we now say at t is equal to 0. At t is equal to 0. If t is equal to 0, it means anywhere we see t, we put 0. It then implies that exponential I 0 is equal to exponential 0. And anything raised to the power of 0 is equal to 1. So we move over to this side to write our characteristic function properly. To write our characteristic function properly. So we get, for more on this topic, you can subscribe to this channel. So to get our characteristic function, we have at t is equal to 0, it means we have pi, because this becomes what? 1, all over 1 minus q squared. So from probability, we know that q plus p is equal to 1, which implies that p is equal to 1 minus q. So anytime we see 1 minus q, we put p. It then means that our characteristic function for the first derivative is equal to pi all over p squared, which is the same thing as pi all over p squared. Of course, if this cancel this, we have I all over p. So we can now write the expected value of x. We can now write the expected value of x. So we move over to this other side. So our expected value of x, which is equal to negative I, our characteristic function at t is equal to 0 is equal to, we have this at t equal to 0, at t equal to 0, we have I all over p. So we have here, because of this negative sign, we have negative I times I all over p. So our expected value of x is equal to negative I squared all over p. We say, but from the characteristics identity, we know that I squared is equal to negative 1. It then means that our expected value of x is equal to negative into negative 1 all over p, which means 1 all over p. So this becomes our expected value of x. This becomes our expected value of x. So the next thing to do is to find the expected value of x squared. Is to find the expected value of x squared. We also need to note that if we have this as our first derivative, the expected value of x will now be the second derivative of this. So we'll write this over here. We'll write it over here. We shall recall that if this is equal to this, now we move over to this other side. To obtain our expected value of x squared. The reason is because we must obtain this to be able to get our variance, to be able to look for our variance. So our expected value of x is the second derivative of the characteristics function, which is we have to differentiate this function again. So this becomes our u and this becomes our v. So we employ what is called the quotient rule of differentiation. For more on this topic, you need to subscribe to this channel. The quotient rule of differentiation will say that the v the u all over the t, since we are differentiating with respect to t, minus u the v all over the t. So we are differentiating this function now. It then means that our characteristics function for the second derivative is equal to v. This is our v. So we read it as 1 minus q e I t raised to the power of 2. The u all over the t, we differentiate this. The u all over the t, we have it as p. Our characteristics function will also come down to make this square. So we have I squared exponential our characteristics function times t, then minus u. What is our u? This is our u, which is p I exponential I t, which is our characteristic function, multiplied by the v all over the t. So we differentiate this, the v all over the t. If we differentiate this, we get 2 into 1 minus q exponential I t raised to the power of 2 minus 1 times the function we have inside. So if we differentiate this function we have inside, we get negative q I exponential I t. So the characteristics function will come down again, all over v squared. Sorry. So we put our v squared. What is our v? This is v. So we write it as 1 minus q exponential I t. This time we have 2 here. It becomes what? 4. It becomes 4 because of this square. So we can now rearrange. Or we say at t is equal to 0, at t equal to 0, which implies that anywhere we see t, we put 0. And it makes our exponential I 0, our exponential function to be this, which is also equal to this, and is also equal to 1. So the next thing to do is to substitute at t is equal to 0. Anytime, anywhere we see the exponential function, it turns to 1. So we move over to this side to write it out. We should not forget that our expected value of x is equal to 1 all over p, because we will recall it for when we are looking for our variance. So we move over to this other side of the board. For more on this topic, you need to subscribe to this channel. So what we do here is that we write the characteristics function at t is equal to 0. At t is equal to 0, because of space, anywhere we see exponential I t, it becomes 1. So we have 1 minus q raised to the power of t multiplied by p I squared. This becomes 1 minus p I. This becomes 1 multiplied by 2 into 1 minus q. This becomes 1. 2 raised to the 2 minus 1 is 1. So that goes minus q I. This becomes 1 all over 1 minus q raised to the power of 4. So this is what we get at t is equal to 0. The next thing to do is for me to rearrange this. Let us just arrange it. So we have that our characteristic function at t equal to 0 now becomes, let us rewrite this well. Of course, we note that 1 minus q all squared into p I squared minus I multiplied by I will give us, this multiplied by this will give us plus I multiplied by I will give us p q I squared into multiplied by this 2 into 1 minus q all over 1 minus q raised to the power of 4. So we got, from probability we have that q plus p is equal to 1. It then implies that p is equal to 1 minus q. So anytime we see 1 minus q, we put p. It then means that our characteristic function is equal to p squared into p I squared plus pq I squared multiplied by 2p multiplied by 2p all over 1 minus, sorry, 1 minus q is equal to p into p raised to the power of 4. So this is what we get. All we need to do is just to rearrange it. We move over to this other side of the board. For more on this topic, you need to subscribe to this channel. So it then means that our characteristic function for the second derivative at t is equal to 0 will now be p multiplied by t will give us 3p. So we have p3 I squared plus, this is p multiplied by p. We have 2p squared q I squared. So this is what we have all over p4. Of course, we have something similar here, I squared and I squared. So we'll bring it out to give us I squared to be equal to I squared into p3 plus 2p squared then q all over p4. Of course, our expected value of x squared, which is equal to negative I squared, characteristic function at t is equal to 0 is equal to, we can now write this to be negative I squared into, nothing has changed, we have p3 plus 2p squared all over p4. So we have to resolve this. We still move over to the other side of the board. For more on this topic, we need to subscribe to this channel. So we move over to this side of the board. Okay. So we have our expected value of x, our expected value of x squared to be equal to, this means negative into negative 1 multiplied by P3 plus 2P squared Q all over P4. Of course, negative is positive. So we have our expected value of x squared to be equal to P3 plus 2P squared Q all over P4. We can now bring something out. We can now bring P squared to be left with P plus 2Q all over P4. Of course, this can cancel this to remain 2 here, which means that our expected value of x is equal to P plus 2Q all over P squared. So this is what we get for our expected value of x squared. The next thing to do is to look for our variance. So how do we obtain the variance? We also recall, for we to obtain the variance, we move over to this other side of the board. For more on this topic, you need to subscribe to this channel. So we should recall that to obtain our variance of x is equal to our expected value of x squared minus expected value of x squared. So we can recall that our expected value of x, recall that our expected value of x is equal to what we got was 1 all over p, and our expected value of x squared, what we got is p plus 2q all over p squared. So all we need to do is just to substitute this into the variance formula. So for we to do that, we move over to this side of the board. So it then means that our variance of x is equal to, first, we write is p plus 2q all over p squared minus 1 all over p, which is what we got for our expected value of x all squared, which is equal to p plus 2q all over p squared minus 1 all over p squared. If we take the LCM of these two, we have p squared to give us p plus 2q minus 1. Of course, we can still do something, meaning our variance of x can be written as p plus, we can open this to give us P plus, sorry, we have 2Q there. Q plus Q minus 1 all over P squared. So we must resolve that. It then means we move over to this side of the board. So it means that our variance of x is equal to, now from probability, we know that P plus Q is equal to 1. So we have that 1 plus Q minus 1 all over P squared. All over P squared. Of course, this will cancel this. It then means that our variance of x is equal to Q all over P squared. So this is how to obtain the variance for the characteristics function of the geometric distribution. For more on this topic, you need to subscribe to this channel.